Hello, we are Group 5 from Section 3 SEEE 2073 Signal and System. We are going to present Convolution Assignment. Introduction to Convolution. What is meant by convolution? Convolution is an operation that called basic operation that perform image and signal processing. Based on mathematical perspective, convolution is an integral. What is the use of integral? Integral is used to get the area under the graph. Thus, convolution is the process in getting the area of overlap between two signals by shifting one of the signal from negative infinity to infinity. Basically, convolution is an integration depending on the time range to get the output signal in the form of unit step function. Convolution for xt and ht is the interaction between xt and ht and output yt obtained by integration. There are some properties of convolution which is commutativity, associativity, and distributivity. Commutative property means that x convert with h is identical with h convert with x. Next, associativity is the product of convolution for three or more functions that does not depend on the orders of the functions. And lastly, distributivity means that the convolution is distributive over the operation of addition.
Okay, for theory of convolution, based on the question, we were asked to analyze output signal RT for the given LTI system with the input signal ST is product of triangular function and unit step function. This signal will go through the system with equation HT that contain unit step function. Okay, for the mathematical equation for convolution is RT equals to ST convolute with HT. Okay, from that process, we need to integrate the equation that we obtain, which is S tau times with HT minus tau respect to d tau. And the limit for the integration is from negative infinity to infinity. Okay, before we proceed to the mathematical calculation, we must plot the graph of signal HT and ST first to get the pattern of the graph. Okay, we also applied commutativity properties to our convolution operation. Okay, next for the calculation. Okay, for the first step, we convert signal HT to become H tau. And then for the second step, we convert signal ST to become S tau first. And then we apply time reversal to the signal S tau. And we will get graph of S negative tau. And then for the last step, we applied time shifting to the graph of signal S negative tau, which we will get the graph of S negative tau.
Thank you, Asif, for the explanation about the conversion of the signal. And now we go to the third step, which is creating cases depending on the suitable time range and calculate the convolution for each cases. For our first case, we take when t is less than -2. From here, we can see the signal st minus tau is not overlap with signal h tau. Therefore, the result that we get for the integration is 0. Next, for case 2, the time range that we choose is when the t is greater than -2 and less than -1. For the graphical approach, we can see that there is overlap between the two signals from -2 to t. So we get a quadratic function which is 2t squared plus 4t plus 4. Next, for the case 3, the time range that we choose is from -1 to 0. From here also we can see there is some overlap between signal st minus tau and h tau from t -1 to t. And then we make the integration calculation and we get a sum and we get constant which is 3/2. From here we can see there is two magnitude of h tau which is 3 and 2. From here we will see that the area that overlap is from t -1 to 0 for magnitude 3 and from 0 to t for magnitude 2. So basically we just make the integration and then we get a quadratic function which is t squared minus 3. Next, we proceed to the case 5. We choose from t is greater than 1 and less than 2. We can see here they still have a overlap area between the two signal from t minus 1 to 1. Therefore, we get also a quadratic function which is t squared minus 60 plus 2. For the case 6, there is we choose t greater than 2 and there is no overlap between both signal. Therefore, the answer also become 0. So basically, the output signal that we get all is a unit step function of all cases. Next, we proceed to the result.
Okay, so this is our result and discussion for our assignment. So this is RT, which is our output for our question. So this is signal that we get after we had do some calculation, which is that we use mathematical calculation and graphical solution. So this is the time range for our RT, which is our output that we get based on the calculation. So based on the RT signal output for t less than negative 2 and t more than 2 is 0 that we get because of the no overlapping happen in this time range. For t more than negative 2 less than negative 1, we got t squared plus 4t plus 4. For t more than negative 1 less than 0, we got 3 over 2. For t more than 0 less than 1, we got t squared minus 3. Lastly, we got for the t more than 1 less than 2, we got t squared minus 60 plus 2. We're also using MATLAB to do the graphical approaching that we need to do in this task. So for MATLAB, we used to build in function to generate the input signal and LTI system signal. So we use some function that already had in the MATLAB, which is to find the triangle function and unit step function. So some of the function that we learn is triangular pulse that we need to use for the triangular function and Heaviside for the unit step function to find the convolution. So the output signal RT is generated by finding the value of y exists using polyval function and we plot the value that we get. So after we do some coding and then we use some function that we generate the between HT and ST we get the result here. This is ST, graph, and HT and RT after we using the MATLAB carefully. So that's all from our group. So thank you so much for watching.